all 5 super and subclasses relationship. So we need to select one of this, one of this, one of this, one of this, and one of this. Okay. To do that, not simple, not easy, definitely. Understand this. First, person and employee, alumnus, student. Okay? Why don't you take a look at this one? It's a full participation with overlap. Okay? It's an overlap. So each option, option 1, 2, 3, 4, one of the option, each one is a selected one. It's the first option, right? You can see person, you can see employee, you can see alumnus, you can see student, right? What about the employee and staff, faculty, and student? So you can take a look at the employee, right? You can take an employee. And what about the staff? What about the faculty? What about the student assistant?
They are using the third option to represent
Employee type.
relationship with type.
That is third option, right? Employee type. So here, for this super and subclass, option 3 is used. Don't be confused with other. So only for this, option 1 is used. Only for this, the employee type. So third option is used. Then, what about this? Student and graduate student and undergraduate student. Student, graduate, flat, undergraduate, flat, which means the last option, first option is used. What about student assistancy with the student and employee, the multiple inheritance? Where's the student? Student assistant is here, okay? Student assistant here.
It's option 2.
This is option 2. Where can you find the student assistant? It's the last page here. And student assistant flat. Student assistant flat. Student assistant 1 now. Okay? Which means the last option, flag is used. Okay? Then, what else? This one, student assistant research or the teaching. Research, RA flag and TA flag. Okay? So you can find how it can be converted. However, it is true. Without converting this one, sometimes you can directly make this. That may be possible. We will see why later. Okay? However, you should be able to understand how we can get this one because of the process. Okay? Then later, sometimes you can go back and you can change the option depending on the situation. If you need the better performance, then you can combine or you can separate. Okay. So that is. Oh, one more thing. We have seen the union type, right? This is the last part of the EER model. So what is the union type? Like this one. It's a subclass. The superclass, they are union, right? At that time, each superclass has their own primary key, actually. So they are different owner. It's a type of different. So at that time, to make the relationship, we will create the additional primary key. That is called the surrogate key, like the owner ID. Okay? So we are going to create additional, the primary key. So we will add this owner ID as a foreign key, then create the foreign key. That is called the surrogate key. And similarly, we can create the vehicle ID. The vehicle ID will be there's a car and truck. So registered vehicle is we can create the vehicle ID. Vehicle ID is also the primary key of the car. That is the reason primary key of the car and truck. Like this. Okay. This is your homework. So why don't you convert this sheet about tracking database ER model into relational schema diagram. At that time, for example, is there any super and subclasses? I don't think so. No. So, however, you should be careful. Double rectangle. That is weak entity. And also this is a ternary. Ternary, you need to create this one. And also this is weak entity, which means to find the key of visit, you need to identify this. Also, you need to identify this, which means combining this one will be primary key. Not easy. Okay, so why don't you convert this into?
I was about to type it down. Can you repeat?
Do I repeat this one? So, one more time. To identify the primary key of this one, key of the visit, you need to use the identifying relationship. That is this, but unfortunately this is also weak entity. So you need to use this, the identifying relationship. That is the state country, name of state country. So name plus P name, port name plus the start date will be primary key of the visit.
I have a question.
Yes.
Why didn't you choose the other entity, ship?
This one?
The ship.
Ship?
Yeah.
Oh, this is also the weak entity.
No, I mean like from visits, the weak entity, and then you go to the relationship, and then you go up. Yes.
Oh, ship.
Why not?
Because it's a ternary relationship. Ternary relationship. Let me convert. So this is a visit. The visit has the ship S name plus P name. I think that it should be combined. This one, this one, this one, and this one, right? Right. Because it's a ternary relationship. This will be entity, okay? This primary key will be combination of this one, this one, this one, and however, this one is from this one, so the primary key of this one is this, and this one is also borrowing this, yes. Okay. Okay, next. Do you remember when we learned about the model itself? What is a model? It's a group of concepts. It's a kind of constraint, rules. Okay. Also, in addition to such a rule or data structure, modeling provides the operation, how to use such a data structure. Okay. That is a reason. Think about the object-oriented concept, object-oriented modeling. When you define something object, how can you access this? How can you use such an object? Using method. Method can be considered as such an operation of your model. It's the same thing. When we model the relational database model, using the relational database model, we can design such a thing. It's a stop. It's a 2:30. We have a time. So when we design the relational model, we should be able to use such a model database. So in this chapter, we are going to learn how to access, how to use a relational model. It's a kind of relational operation. However, some of students already used or learned about SQL, right? So what is a SQL? Structured query language. That is the programming language to access the data. It's a programming level. Okay? It's kind of interface. That doesn't explain the how to access such a relational schema diagram. Okay? Before we use such a structured query language programming level, we will discuss about how we can access. What is the theoretical approach to access such a model, formal way of model? This is using the which is called relational algebra or relational calculus. Anyone who loves the calculus? Not many. The algebra. What is the algebra, by the way? Most hate subject. So we have in mathematics there are two parts. One is algebra, another one is geometry, right? So these are the two main parts. There are a lot of the variation, but basically the mathematics, the historically mathematics has been developed based on the geometry and algebra. What is the main difference? What is the main difference? Geometry use shape, or some visible. On the other hand, algebra use equation. Okay? So we try to solve actually the same problem. In geometry, in mathematics, we try to solve the same problem but different approach. One of the Pythagorean theorem. One of the example of such a difference, Pythagorean theorem. What is the Pythagorean theorem? A square plus b square is a c square in case of the right triangle, right? So we can prove actually this one using equation. Also using the shape, we can draw the area, and by combining this, we can get this area, something like that. Without using equation, actually we can prove the same Pythagorean theorem, geometrical approach. Okay, so in this, the relational algebra to access the relational model, we are going to use such an algebraic approach, which means we are going to define something equation, something the operation. Okay, then we prove how to access such a relational data. Okay, so we are going to start from some unary operation. Before that, so what is this? This is our table relation. So we can view table as a set of tuples or a set of attributes or columns or rows. Okay? Which means we try to access the relational data as tuple level. Okay? This way. Okay? So, for example, the first one is selection. The selection operation. If we want to, we can discuss outside. If that is not related. Okay? Sometimes it's okay, sometimes bothering me. Okay? Sorry about that. So this is a select operation. Because I'm not blaming you. I believe that teaching something is kind of the performance, I believe. Sometimes if I lose my pace, I totally mess up the other. Okay? That is the reason sometimes it's very annoying me. Okay? But sometimes it's okay, sometimes not. Okay? So please understand me. I believe the teaching is kind of the performance, like if somebody perform the comedy, but it's really, right? So, please understand. Especially when I have the very large class. So, that is. Right now, we are. That was one of the reasons I really yelling the last time. When it's sometimes hard to resume such a performance survey. So this is let's go back to the basic. Yeah. This is our table, our relation that consists of the number of tuples, number of attributes. Okay, so we can access in terms of the data this way. Also, we can access the data in this way because that's the definition. That's the relation. So first, we can access the data such a way using the sigma. This is the Greek in terms of Greek letter. It's a sigma. So we can specify. We can specify the relation, name of relation over here, then sigma, which means we'd like to access the relation in terms of a tuple, in terms of rows. Okay? At that time, if I want to access all the data, we can just give this example, but mostly we wanna limit the data. For example, I'd like to retrieve the employee who works for department number 4, for example. At that time, we can give such a condition as a subscript of this. At this time, this is called relational operation. And this is the relation, input relation. Also, one more important thing is all the output of all relational operation is also relation. Why? For example, I'd like to return the only employee department number 4. So this is a department number 4 relation. What is a relation? Relation is a group of data. So this is also group of the data. So this output of any relational operation is also relation. Okay? That's the very important thing. Which means, is it possible to combine like this?
Yeah.
Yes, because this is the relation, so output of the relation can be input of another relation. So you can give the another condition like the salary is higher than 3,000. Okay. Which means I'd like to retrieve the employee who works for department number 4, and also salary is higher than 3,000. So this is also relation. At that time, if you combine many relational operations, this is called relational expression. So our goal is to make the relational expression, okay, that can specify the specific data to be retrieved from the relation. So this is the first one is a select. This is called the select operation. Select operation, using select operation, we can specify a number of tuples, number of the data. Okay, so that is a select. For example, this example, to select the employee tuples whose department number is 4, or those whose salary is greater than 3,000. The following notation. Yes, this is the employee whose department number is 4, and this one is whose whose salary is bigger than 3,000. Okay, so at that time, this is the select condition. Okay. In select condition, as you can see, it's obvious that it has the commutative, right? What is the commutative? A plus B is equal to B plus A. So you can change the order. Definitely, when you select the data, you can apply this one and this one. It's the same thing in terms of output. However, it may be different in terms of performance. So later we will see such a difference. So, but in terms of output, it's the same thing. So sigma is the selection is the commutative, and also you can combine into one. So which means in this case you can select, and salary is bigger than 300, and you can add a logical operation and or the annual is equal to 4 and include. So this is the select operation. Okay, so what about this? So from this example, how many? 1, 2, 3, 4, 5, 6, 7, 8. We have the 8 employees, so we are going to apply this select operation. What does that mean? We'd like to retrieve employee who works for department number 4 and salary is higher than 225,000, or from the department number 5 whose salary is 3,000. Okay, 30,000. Higher than 30,000. That is Franklin Wong, Jennifer Wallace, and Ramesh Narayan. Okay, 3. As you can see, this is also relation. Okay, this is a group of data. The last one today. So next one is a project, because we can see the table or relation as a group of attributes, like this one, column by column. So why don't we specify the data, return data by column? That is project. Project operation. Project operation is we can use the pi. So which means it's so simple. Pi and name of attribute employee and specify the list of column that you wanna retrieve. Okay? Like this one. For example, employee, the last name, first name, and salary. Return the employee. So same thing. Output of this one also relation, which means we can use combine this one with select. So for example, you can use select. The condition is salary is higher than 3,000, like this. Okay. Then we regard this one as relational expression. So relational expression consists of a number of relational operations. So later you will realize the importance of such a relational algebra and relational operation when you deal with query performance, query optimized. Okay. So this is the last one, last slide. Okay, from employee, last name, first name, salary, last name, first name, salary. Okay, so we can get the 2, 3, 4, 5, 6, 7, 8. But what about this one? From the same table, sex and salary, how many? 2, 3, 4, 5, 6, 7. Actually, supposed to be 8, but we get only 7. For this. Why?
She doesn't have a salary.
It's wrong? No, it's correct. Yeah, duplication. Which one is duplicate? Man 3,000, man 40,000, female 25, female 43, man 36, female 25. This is a duplicate. So why? This one does not allow duplicate.
Distinct.
Because this is also relation. Relation does not allow duplicate data. Why? Because it has primary key. Primary key means it's a unique. If the data should be unique, so this is the last thing in terms of the relational expression. Relational algebra does not allow duplicate data. So in case of the duplicate data, you can automatically remove such a redundant information. That is the main difference between SQL and relational algebra, relational expression. We will see more examples next class. Okay. Any question? Okay, thank you. And we will see Thursday. Don't forget you have the